Again, my name is Trent Dragseth. I'm the applications engineer with Electro Industries. Today we'll be discussing going over the Nexus 1500 Plus meter, historical logs, and power quality events. So let's get started. All right, so if you joined the last 2 days of webinars, you've already seen this part using Communicator. I'm using Communicator PQA. You may have the Communicator EXT 4.0 version. For everything that I'm about to show you navigation-wise, the pieces of software are identical. So we can, for following along purposes, you won't have to do anything different than what I'm doing here. Clicking the Connect button will bring up this prompt, which you may already be familiar with. This is connecting to an online meter. Anyone who wants to connect to a Nexus 1500 Plus meter to play around with it, you can use this IP address, or in this case, web address, mynexusmeter.com. The Nexus port is 508. Reach out to us after this webinar if you need more information on connecting to this meter. So this meter does have security enabled. Security is an option on the meters. Once you log into the meter, you'll see this device status screen with the meter name, device type, serial number. Since I'll be talking about the logs and power quality events, when you get a meter, this device is the meter name. This is also the name of the log file that gets saved onto your computer once you retrieve logs from this meter. So hit OK here. When you're ready to retrieve logs, you can either click this log status button or the retrieve log button on the Nexus 1500 Plus meter. Both these buttons take you to the same location. The log status for the Nexus 1500 meter, this is the serial number of the meter. We have 8 historical logs. We have out of limit events. We have flicker monitoring, waveform recording, power quality events. I've already retrieved the logs from this meter, so we don't have to sit through the entire log retrieval process. But if you were to retrieve the logs for the first time from the meter, any log you wish to retrieve, you will check the select box for any or all of the logs. Any items that don't have any records stored in the logs would not let you check them. And the system events log is always checked. It does not let you uncheck it. Once I get into the log, I'll show you, but the system events is an administrative type log to check to see what type of activity has been done to this meter. So I already have the log viewer for this meter popped up. Once you retrieve the logs, once Communicator has successfully retrieved the logs and converted them, log viewer automatically pops up. If you've already retrieved logs from a meter and you want to get to those logs again offline, not connected to a meter, you can click this open log button. Any meter logs that you've retrieved will show up in your open log dialog. If you've got logs that somebody sent you from a meter that don't show up here, when you click select log, this will take you to the directory in File Explorer where your logs are saved. So navigating log viewer, we have 3 sections on the main page. You can select your time range. We default to 1 year. When you click on time range, you can set a custom time if you wanted to see for the month of April, month of March, or just a specific day. You could go back for the previous few hours, days, weeks, months, or years. For the sake of loading time, when we're looking at the logs, I'll just go back for a month. Down here in select data, this is the meter that I'm viewing a log for. This is that meter name. So when you get a meter and you name it for a substation, a building, a panel that it's monitoring, that name will also show up in this area. If you are already in Log Viewer and wanted to view a different log, you can click this meter 1 button and that will open up the meter log profile. The data points button here allows you to choose which points you want to view in your historical trends window. Anything that the meter is recording that you've already retrieved will show up in here. So whether you have a Shark or a Nexus meter, this is the same process. If you already have some Nexus 1500 meter logs and you don't see these exact same values, that's because these logs are customizable and they could have been set up differently. So say we wanted to look at the watts, you can select an item. You can hold Shift while you select an item to select multiple. You can also double click on an item. Any points that are selected on the right side are what you will see in historical trends. When you open up the historical trends, you will not see all the information over here. If you choose to, you could add every point from the meter to the right side, but for sake of being able to read, we only add a couple at a time. Go ahead and click OK to set those points. Now over here on the right is how you view all the information from the meter. I'll just start at the top. We have the view database status. So this will bring up a prompt, which database status you wish to view. These are all points that we've retrieved from the meter. If I hadn't retrieved historical logs 3 through 8, these would say unavailable. So if I wanted to look at information for the waveform triggers, I would select that, click View. We have the device type, the name, the ID or the serial number. This is the directory where this log is stored. This is the size in bytes. I've only downloaded from this meter once, and that was this morning. This is the version of the DB file. And the data log here, waveforms. The first date of waveforms that's available is from December 28th of last year. And the latest waveform retrieval or capture was on the 23rd of April. Now we've got 38 waveform captures in this log file. The system events log, this is that administrative log I was talking about. Anytime a change is made to the meter, this field gets updated. So anytime you set the clock in the meter, anytime you make a programming settings change, anytime you reset any of the parameters such as demand, clear out any of the logs, any energy resets. So here I did a couple events this morning just to show you. We did some log downloads. If someone tries to log into a meter that's password protected, it will log when they tried to log in and tell you that an invalid password was used. When someone connects to the meter, logs in, and it was successful, that also gets logged as well. And so in this case, I actually changed the time of the meter. So that was at 11:13, which it's not even 11:13 yet. So what happened is this meter was about 30 minutes fast. So the previous time was 11:13, and I changed that this morning. So now the meter is at the correct time. Next, we have the historical trends. Historical trends are the information from historical logs 1 through 8. So anything that's being recorded on an interval basis. If you joined the webinar yesterday, Norman Clark went over that. If you weren't there for the webinar yesterday, in the profile, you can set up historical logs 1 through 8 to record any parameter that's available inside the meter. And you can also set that up to record at any interval from 24 hours to 30 minutes to 10 minutes to 1 minute to 1 second to as fast as every 100 to 200 milliseconds. So if I added watts, frequency, demand, scaled energy, you can add any or all of these values. Hit OK. This will open up the historical trends. And now I have an Excel type spreadsheet where you have your timestamp on the left. This is information from the Nexus 1500 named meter. We have our scaled energy, quadrants 1 and 4, high-speed updated watts, high-speed updated frequency, and our cumulative demand. This is being recorded every 15 minutes. Again, if we were recording every 1 minute, that would update to reflect that. If you left-click where it says timestamp, that highlights all of the points. You can copy these points and paste them directly into an Excel spreadsheet. You can also graph any of these points that you're seeing. So when you hit graph, it doesn't graph all 4 points automatically. It lets you choose. In the case of graphing, our graphing feature on Log Viewer uses a 1-axis Y scale. So if we were to graph high-speed watts and cumulative demand, those values should be pretty similar. But if I were to also add frequency, when we look at this graph, and I'm looking at a whole month, but I've only retrieved for May 1st, which is why this looks so short. We have our watts, our cumulative demand, and then down here it looks like it's 0, but this is actually our frequency because it's only at 60 hertz. So we recommend, if you're going to use the Log Viewer charting and graphing feature, that you only graph items that are similar in numerical value. Since I'm looking at per month, you can navigate month to month. So if I navigate back, I'm at April. And the data that I have stops at April. If you were doing log retrievals on the meter on a daily, weekly, or monthly basis for the last few years, you would be able to navigate back as far back as you have information for. You can left click and drag to zoom in on a specific area. Anytime you're done looking at this, you can click undo zoom, and that will get you back to the whole month. This little dashed line down here at the bottom, this is the average of the value that you're looking at. So the blue line is high-speed watts. So the average of all of these points that we're seeing for the month of April, it averages out to about 16,500 or 16.5 kW. If we look at this meter on a week basis, April's not probably a very good month to look at because of the COVID events happening. But on a typical office building, you should expect to see high usage on a weekday, low usage at night, spike in usage again. The weekend should be pretty empty. Monday, it peaks a little bit. Tuesday, Wednesday. So we do still have a couple people at our facility, but for the most part, it is shut down. Like I'm guessing many of you have as well right now. While you're looking at this information, we also give you the option to export into any one of these picture formats. You can also export the text or the data that's used to make these graphs. So this will export the values made for these points. So you can paste this into Excel to create your own graph in Excel. You can export this to the clipboard, to a file, or if you have a printer connected to your computer that's online, you'd be able to send this directly to a printer as well. This max min button, this allows you to see your highest and lowest value for the week of April that we're looking at, the 1st through the 9th. Next, we have the waveform. I'm going to skip over waveform and go to power quality first. Waveform and power quality go hand in hand with each other. The waveform section actually captures the sine wave so you can see what's happening during an event. The power quality log keeps track of all of those events and the duration of those events. So here we can see the 23rd, we had a couple events that lasted 25 milliseconds. April 13th, we had some events that lasted 87 milliseconds. So when you're looking at waveforms, if you look at a waveform and there's a trigger and you don't see a whole lot of sag or surge, it might be because the duration is so short. So if we went back to waveforms and looked at 413 at 12:55 p.m., so we have 413, 12:55 p.m. If I double click on this line, give it a couple minutes to draw and catch up. Before I bring up the graph, you'll also notice the duration here. It says 3,000 milliseconds. This is not indicating how long the event lasted. This is indicating how long the waveform capture took place. So the waveform capture window, when you see it, it's over the course of 3 seconds. So the actual event only took place for 89 milliseconds, not 3 seconds. So here you can see we have they're very small. So hopefully most of you have a larger screen, but we have VAN, BN, CN, current A, B, and C. So the trigger here was a sag on A and C phases. You can see it here. If we wanted to zoom in on this, if you check the box for VCN and VAN and double click, that will bring up A and C phase voltage waveform captures. And just like the graphing screen, if you left click and drag to the area where the sag is, that will zoom into that area. So we also do annotations. So you can see the sag started around here. You can right click on this area. Annotations right now is grayed out because I'm looking at two different phases. So if I go back, zoom in on just one of the phases. If I set an annotation here, I can set a range. I can set another range. And now it shows from where I set range 1 to range 2, or Mark 2, Mark 1 and Mark 2, the duration was 114.45 milliseconds. When you are looking at one phase of voltage, we have an RMS voltage line. So right now we're looking at peak voltages. This line will show you your RMS voltage, so you can see where RMS voltage actually was affected. You'll see that I added that range on the A phase, but the range tracks between A, B, C voltages and currents. So if we zoomed in on A phase voltage and current, you'll be able to see that duration, and you can look at what happened to the current while the voltage was being affected. In addition to setting a range, we can also set a note. So if something happened here, say there was a ATS switching or a piece of equipment malfunctioned, basically whatever happened, instead of having to try and remember this when you come back, you can add a note. And now this note is saved. So if I exit out of here and come back in, that range that I set and that note stay. So if you come back 3 months later having to talk about an event that happened, you don't have to try and remember exactly what happened. You have notes that will remind you. All right, so we can also view waveform details. So now, in addition to seeing the actual waveform, we show you the RMS voltage, the block, the peak voltage, the crest, and total harmonic distortion for this cycle. So you can scroll through to see during the event what the harmonics was looking like, what the crest or K factor looked like through the entire waveform capture. You can export this picture. You can also export the data that's used to create this graph. So again, if you don't like our graphing techniques, you can paste all of this information into an Excel spreadsheet and create your own graph. If there's any more questions, we can come back to that during the Q&A session. But for the sake of time, I'll just continue on. Back in the power quality section where you have the duration of the events, what the condition was, the channel that it happened on, and the value, we do a power quality graph. It used to be called Sabima curve. Current name, as far as I'm aware, is PQ graph now. So what this does is, instead of having to go through all the waveforms and try and determine what happened, this power quality graph is used to determine if a power quality event is something that you need to worry about that could affect pieces of equipment on your system. This power quality graph is meant to be used as a guideline. It is not a hard and fast rule. In this case, all of our power quality events that we're looking at fall in the area which is okay, which is this area here. Any surges that happen in this area or voltage sags that happen down here, these are items that you need to potentially be concerned about affecting pieces of equipment on your system, which could be fixed by putting surge suppressors or line conditioners on the equipment, or protecting your whole building using some sort of protection. These events are considered okay, and any equipment that's in our facility that's not highly sensitive equipment should be able to withstand these events and ride through them. We also have an out of limit log. So this is similar to the power quality event, but where the power quality events only look at voltages, the limit log you can set up to look at voltage, current, frequency, power factor, watts, demand, anything but the energy, as energy is an accumulated value, and at one point, once it goes above the limit, it'll stay above the limit until it rolls over. So once this pops up, this will show you the start date and time and end date and time of the event, how long it lasted, in this case 0.1 second, 0.09 seconds. So limits are in seconds, power quality events are in milliseconds for timestamps and durations. So we had sags on current. In this case, most of our issues were sags on current. But this is just a quick show of what happened on what phase. We could set up limits for voltage imbalance. This could be used if you had an issue with getting A, B, and C phase fed consistently. So status change, control inputs, these are for option cards, which this meter does not have. That's why these are grayed out. If you are using inputs to monitor status or using relay output control, if any of those events did occur, these buttons would be highlighted so you could see that information. I know Norman touched on it a little bit yesterday, but we have PQ diff and ComTrade file formats so that if you choose, you can use a piece of software that does power quality reporting and export the logs from this meter into those file formats to bring into a third-party power quality software. On that note, our Nexus 1500 plus meter, our Nexus 1450 meter, those both provide their own EN 5160 power quality report. So if you don't have these third-party power quality softwares, these two meters will give you that power quality information. So if I click on EN5160, this will show you, since I'm only looking at the previous month, I have a power quality report from April. So we're looking at the power quality event from April. That's why we're only seeing 3 here. So you get a summary of each week. These EN5160 reports are over 7 days. So you can see if anything is passed, failed, anything that's not being recorded is unavailable. Since we had a failure here, you can right click on this and it will generate the power quality report. So this will create a PDF file. So if you do need to send this power quality report to somebody, they do not need our software to view it. You can just save the PDF, send it to whoever needs to see it, and they wouldn't have to install software for that. So in this case, the failure was a rapid voltage change. So if we scroll down here, the first page is the report details. So this is how the meter is set up. Its operational frequency, the nominal voltage. So you'll see that the voltage phase to neutral here is 1,222 volts. We're using a step down transformer to step this down to 120. So that's why our nominal voltage is 120, even though our full scale voltage is 1,222. So then even though items have passed, they still show up on this report. So supply voltage variations. Here's the rapid voltage changes that failed. So we gave you a little description as to what that means. These percentages are set up in the profile. We set it to default for the IEC and IEEE specifications. But if you need to change that, or if those specifications change in the future, you're able to change those as well. So in here, we allow 7 changes that are greater than or less than 6%. And on A phase voltage, we had 8 events. We had 12 on B phase, and we had 11 on C phase. So for the most part, we were okay, but we did have a few events that happened on SAG and a surge event. We've also got flicker monitoring, and I know Norman touched on it a little bit yesterday. Flicker monitoring looks at voltage and current variations. The most visible evidence of flicker would be on fluorescent lights. If you notice fluorescent lights brightening and dimming throughout the day, that could be an effect of flicker. You could have flicker and not notice the brightening and dimming of fluorescent lights. It is a long-term cause of eye strain, which can cause eye problems in the future. That's why people are starting to use flicker monitors to check to see if lighting loads need to have some sort of protection or line conditioning to eliminate the brightening and dimming effect. So we have supply voltage dips. We didn't have any of those for that week. We had short interruptions of supply voltage, but they were not anything that happened long enough to be considered a failure point. We didn't have any long interruptions of supply voltage. So those are interruptions lasting longer than 3 minutes. Any temporary power frequency over voltage. We didn't have any of those events. We didn't have any harmonics issues. So for the most part, we were okay. We had a couple voltage variations. The flicker monitor. This will just show you how much the voltage and frequency has changed. Flicker does two testing types. It does a short-term test and a long-term test. The default set points for those are 10 minutes for the short term and 2 hours for the long term. These parameters are customizable in the meter if you wanted to change those as well. But default and typical practice is 10 minutes and 2 hours. So we have A, B, and C phase voltage variations. This is how much the voltage varied, not what the voltage was. So on May 1st, our short-term test at 1020, it only varied 0.08 volts for that 10-minute period. And then here was the end of the long-term test. So this is the 2-hour test. So in 2 hours, we only varied 0.04 volts, 0.09, and 0.05 volts. So you can graph this information. So PST is short-term and PLT is long-term for flicker. So if we graph these short-term values, we'll have to see. Oh, I won't waste time with this. We'll have to set a custom date to get these popped up, but you can graph this. You can export these points into Excel just like anything else to see how much flicker you have at any point during the day. And that's if you choose not to use the power quality report, which will monitor the flicker for you anyway. Okay. So there's a lot of information in the logs. I may have gone through some points too quick. So I will open it up to questions if there's any questions. If you need more information or any help looking at a log that you may have, you can always reach out to us at support@electroind.com or call in to Electro Industries, and we're more than willing to help you look at your information.